All right, let's look at the final question here now for how fast is the object moving at x equals 30 meters. We're going to look at this starting at 20 meters and looking at it ending at 30 meters. So really just concerned with this final little section here, this triangle. Again, we use the work energy theorem to do this, which tells us the work that's done is equal to a change in kinetic energy. We're going to set this up really similarly to what we just did. I know that the work done is going to be equal to the kinetic energy at 30 meters minus however much kinetic energy my object has at 20 meters. And again, we did a lot of this work already. We calculated the area or the work to be 500 joules. I don't know the kinetic energy at 30 meters, but I can use that to find the velocity as soon as I get a number. So we're just going to leave that as an unknown. And we calculated the kinetic energy at 20 meters to be 2,019.6 joules in our last video. So we have that number as well. So again, we do a little bit of algebra. The kinetic energy at 30 meters then, 2,519.6 joules. And just like we did before, we're going to set that equal to how we calculate kinetic energy, 1/2 mv squared. We ultimately then get a speed of our object to be 31.75 meters per second. So again, let's come back to our graph where we made some initial notations here in the beginning. At first, my object was moving at 2.8 meters per second, had a whole bunch of positive work done to it. It got faster, it increased energy, moved at 28.42 meters per second. Now, look at what happened again. I did more positive work. I did less work than before, but I still did positive work. I'm adding energy to our system. It makes sense then that our object is now moving at 31.75 meters per second. From the beginning to the middle to the end, all I've done is positive work. So all my object can do is increase in energy and increase in how fast it's going. Be careful, because one of the things that can be misleading is the fact that this section of the force versus displacement graph does have a negative slope, showing you that the force is decreasing. That doesn't mean that our speed is decreasing though, and it doesn't mean that work is being done negatively to remove energy. It just means that you are applying less force. Still positive force, still positive work, just less force than before.